Hello. So, our last topic that we're going to be talking about is dilations. And dilations, I think I mentioned earlier in the year when we did transformations, and so far we've only done congruence transformations. If you remember earlier in the year, we did reflections, rotations, and translations. And then I mentioned that dilations are a similarity transformation. So we save those for the similarity unit because it just fits a little bit better. So there are different types of dilations that we're going to be doing. We'll be doing them on and off the coordinate plane. Today is pretty basic. We're starting off today with dilations, which are using the origin as the center of dilation. So just to define what a dilation is, it's a transformation that produces an image that is the same shape as the original, but different sizes, which may sound very similar to the definition of similar. If you remember from earlier in the year not earlier in the year, earlier in this unit, I should say, where we defined similar figures. They're the same shape but different sizes. Oops, I didn't mean to write different similar. My bad. Okay, different. This is why I can't talk and write at the same time as the original, but different sizes. There we go. Okay, so a dilation is similar to the original figure. So anytime you have a dilation, your pre-image and your image will always be similar. Dilations are centered around the origin. That's what I just said a second ago, unless otherwise stated. So we're starting off today with dilations around the origin. We'll probably tomorrow move on to ones that are not based on the origin. Okay, next we have scale factor. Scale factor, we already know, we learned in similarity, is basically the ratio of sides. But for dilations, it's always written in one way. So the scale factor for dilations is always the image over the pre-image. Remember, image is the new one and pre-image is the old one or the original one. So it's always new side length over old side length. If the scale factor is greater than 1, the figure becomes bigger. If the scale factor is between 0 and 1, so say a half, it becomes smaller. Okay, so just like the other types of transformations that we learned earlier in the year, there's a way to write the rule for dilations. Right here is how you write the rule. XY maps to FX, FY. That's really F times X, F times Y. It's multiplication, where F represents the scale factor. So what that basically means is when you have the scale factor, you multiply the X and Y coordinates by whatever the scale factor is. So in this first example, it says if the scale factor is 3, how would you write the rule? So you would write the rule as XY maps to 3x, 3y. So you're just multiplying all the x's and y's by 3. Now I should mention again that this is only when the scale factor, when the center of dilation is 0, 0, the origin. Once we get into other types of dilations, you don't simply just multiply. It's different. Okay, so here's an example. We're given the coordinates of A, B, C, and we're asked what are the coordinates of the image with the scale, if we dilated this with the scale factor of 4. So first I'm going to write the rule. So it's going to be 4x, 4y. So now to get A prime, B prime, C prime, remember we put the prime symbol for the image versus the pre-image is just regular A. I'm just going to multiply everything by 4. So 0, 2 is going to be 0, 8. Multiply both of those by 4. B prime, 4, 4 is going to turn into 16, 16. C prime, negative 1, 4 is going to turn into negative 4, 16. So that would be your new coordinates. That would be your image. And on the next example, we're going to talk a little bit about what happens when you graph them and some things that are true. So I'm going to graph. It says quadrilateral PQRS has vertices at negative 2, 4, 4. I'm going to plot these. So negative 2, 4 is going to be P. Q is going to be 4, 4. R is going to be 4, negative 2. S is going to be negative 4, negative 4. And then you want to use a ruler, which you guys should all have rulers that I either gave you or you purchased. Use a ruler to connect them with a nice, neat line. Okay, so it says it's dilated by a scale factor of 1/2. So that means that we're going to multiply all of these points by a half or divide by 2. Same thing. So P prime is now going to be negative 1, 2. Q prime will be 2, 2. R prime will be 2, negative 1. S prime is going to be negative 2, negative 2. I'm going to plot those in a different color. I'll do red. So now plot them. P prime, negative 1, 2. Q prime, 2, 2. R prime, 2, negative 1. S prime, negative 2, negative 2. Okay, connect those using a ruler. Okay, so some things that I want to talk about. Well, one thing that is asked right here. Oh, well, it's part D. It's okay. We'll get to that in a second. So some things that I want to point out that are true. When you have a dilation with the image and the pre-image both plotted, one thing that's true is that the side lengths of your image and pre-image are parallel. So like this is parallel to this is parallel to this, and so on. All around. I mean, I guess I could mark all of them, may as well. These are all going to be parallel, and that will always happen. The only time it doesn't happen is if one of the sides goes through the center of dilation, goes through the origin, in which case the lines would be coinciding. They'd be on top of each other. They wouldn't be parallel. So that's one thing that's true. Something else you can do to check your answer is if you grab a ruler and line up Q and Q prime and connect them, they should always line up to the origin. S and S prime, if I were to connect S and S prime, see how they line up exactly with the origin. P and P prime line up with the origin. R and R prime line up with the origin. So that's another way. Actually, I don't really like all that yellow. I'm going to get rid of it. That's another way you can tell if your dilations are accurate. The image and pre-image side lengths should be parallel, and the image and pre-image points should line up to the center of dilation. Okay, the next part C, says verify these quadrilaterals are similar by comparing the ratios of lengths. It's supposed to say side lengths. So sometimes you might be asked to verify that shapes are similar. And to do that, you have to remember that shapes are similar when their side lengths are proportional. So basically we're going to write out, so let's see. Remember too that the scale factor is new over old up here, right? Remember we learned that right here. So I'm going to take the prime segments and put them over the pre-image segments. So for example, P prime, Q prime, I can just count is 1, 2, 3 units. PQ, oops, I don't need two equal signs here. PQ was 6, which see that reduces to 1/2, which was the scale factor. So that's what we want. Let's do Q prime, R prime, and QR. Also 3 and 6, which reduces to 1/2. Now the other 4, unfortunately, we cannot just count because they're diagonal lines. So we're just going to do, you can either do Pythagorean theorem, like turn this into a right triangle, or you could do distance formula. I'm going to do distance formula, but either way would work. So if I'm going to do S prime, R prime, and SR, I have to do distance formula first. So let's see, where can I do that? I'm going to do it off to the side, like over here. So S prime, R prime. Where are my points? Oh boy. S prime, R prime is going to be, where's S? -4 minus 4 squared plus -4 minus -2 squared. So it's going to be -8. And then it's going to be -2. So that's going to be the square root of 64, and 4 is 68, which I am going to figure out the decimal for that. second to grab my calculator. So the square root of 68 is going to be a little bit over 8. 8.25, we'll say. Okay, I'll do SR above it. Oh, I just did SR. Oh boy, I'm all messed up. So that was SR. Let's do S prime, R prime. So that's going to be, oh, our new points right here. Okay, -2 minus 2 squared. And then -2 minus -1 squared. So let's see, it's going to be 4 squared, which is 16, and that's going to be -1 squared, which is 1. So it's going to be square root of 17, which is a little over 4, just like I said. So 17 square root of that, 4.12. Which this 8.25 was rounded up, so it's pretty accurate. So now that's going to be 4.12 over 8.25. For the sake of this video, I'm not going to do all of them just so it's not super long, but you know, you would do the same thing. I'm pretty sure they end up being the same as S and R. So let's see, P prime, S prime, and PS, they do end up being 4.12 and 8.25, but you would want to show that out. And so that verifies that the quadrilaterals are similar by checking their side lengths, ratios of their side lengths. Part D, what do you notice about the angle measures of the two figures? So since they're similar, remember the angles are the same. So all the angles are congruent. Q and Q prime are congruent, R and R prime, S prime and S, and then P and P prime. They're all congruent. Well, not all to each other, but the, let's say, image and pre-image angles are congruent. Okay, so that's what happens when figures are similar. A couple more examples. Example 4, if the scale factor of dilation is 5/2, how would you rate the general rule? Is it enlargement or reduction? Basically, does it get bigger or smaller? So the rule would be xy maps to 5/2 x, 5/2 y. And since 5/2 is bigger than 1, it would be an enlargement. Okay, next example. I give you A prime, B prime, C prime, D prime is the dilation of A, B, C, D. Find the scale factor. So there's different ways you can find the scale factor. If I had side lengths here that were horizontal or vertical, I'd probably just count them and compare the side lengths. But I don't have that. So I could do distance formula to get side lengths. But kind of an easier way is when you know this only works when the center of dilation is 0, 0. You can take the coordinates and put them over each other, new over old. So like A prime is 2, 0. That's the new one. A is 6, 0. So like if you kind of like thought about making it as a fraction and just reduce them, 2 over 6 is 1/3. And so if you think about it, if I took 1/3 and multiplied all of these pre-image points by 1/3, I would get all of these image points. So you can just use the ordered pairs and put the ordered pairs over each other. You just want to make sure you're being consistent with new over old. So the scale factor here is 1/3. Pretty easy. The next one, it says we have a dilation of a scale factor of 2. So let's write out our original ordered pairs. Y was -1, 2. Don't know what happened there. 2. Let me erase it. -1, 2. There we go. And then so y prime, we're just going to multiply both of those by 2. So it's going to be -2, 4. Z is 1, 1. Mapping to Z prime, which is going to be 2, 2. Multiply both of them by 2. x is -1, -1, mapping to x prime, which is -2, -2. So then if we plotted them, -2 is going to be here. 2, 2 is here. And then -2, 4. There we go. Notice before when I said that the image and pre-image sides were parallel, I said there's one exception when the pre-image goes through the origin or the center of dilation. That's what I meant here. See how these aren't parallel? XZ and X prime, Z prime, they coincide. They're on top of each other, but the rest are parallel. So that's that. And then let's see this last question. What will the coordinates of point Y double prime be after a reflection over the x-axis? So let's use a different color. So Y prime is here. If I were to reflect that over the x-axis, remember how to do that? Here's the x-axis. So Y is Y prime rather is 1, 2, 3, 4 units. So 1, 2, 3, 4 units. Here would be Y double prime. So it would be -2, -4. Little reflection review. So those are just a few examples of what you can do with dilations. I did getting the scale factor, taking the scale factor and making a dilation. That should pretty much cover everything. The examples that you're going to do are not, I'm not going to say they're exactly like this, but it's the same idea. So I tried to do a little bit of everything. But if you do need help, just let me know. I'm more than happy to help you. All right, that's it for today, and have a great day. I'll see you tomorrow.